Building a Victorian factory wasn't like putting together a garden shed. There were no second chances, and a single miscalculation didn't mean a wobbly wall, but several stories of iron and brick collapsing on everyone inside. Industrial pioneers learned this the hard way, usually right after someone confidently declared that should hold just fine. I once watched a documentary about a building collapse. Terrifying stuff. Now imagine that, but with steam boilers ready to explode. These weren't simple buildings you could knock together in a few months. Victorian factories were industrial cathedrals, containing more iron than medieval castles and enough bricks to pave roads for miles. They needed foundations that could handle machines heavier than houses, boilers that could explode like bombs, and power systems that would give modern engineers nightmares. But before you could stack a single brick, you had to win the land. And that was a battle all its own. Victorian industrialists couldn't just point at a map and say, "Build my factory there." They needed a location that would keep their operation running efficiently for decades, and getting it wrong meant watching profits drain away forever. It's like choosing where to open a restaurant, except your restaurant weighs 10,000 tons and needs a river to survive. Water was the first non-negotiable requirement. Steam engines were thirsty beasts, and we're not talking about a few buckets here. A medium-sized textile mill could gulp down 50,000 gallons of water every single day. That's enough to fill about 3 swimming pools, daily. And the engine didn't care if it was raining or drought. I get cranky without my morning coffee. These machines would literally explode without their water. Some factory owners spent fortunes building private reservoirs and canal connections just to guarantee supply. Records show that water rights disputes could drag through courts for years, with factory owners and farmers fighting over every stream and spring like medieval lords battling over territory. Coal proximity was equally critical. Steam engines burned through coal like teenagers burned through snacks, except there were no low-calorie options. A large factory might consume 50 tons of coal per week, and every mile that coal had to travel added to your operating costs. Factory owners did the math obsessively, and get this, building just 10 miles from a coal field instead of right next to it could add thousands of pounds to annual expenses. Some calculations from the era show that transportation costs could actually exceed the cost of the coal itself. Talk about location, location, location. Rail connections were the Victorian equivalent of highway access. By the 1840s, smart industrialists knew that being near a railway line was practically mandatory. You needed raw materials coming in and finished goods going out, and horse-drawn carts weren't going to cut it at industrial scale. Factory records show some owners paying premium prices for land near planned railway routes, essentially betting on infrastructure that hadn't even been built yet. Pretty gutsy investment strategy. But finding the perfect spot was only half the battle. Actually acquiring the land could turn into a nightmare that would make modern real estate deals look like buying a sandwich. Aristocratic landowners weren't always eager to sell their countryside estates to factory owners, no matter how much money was offered. Some lords considered industry beneath their dignity and refused to have smoking chimneys visible from their manor houses. One particularly stubborn earl in Lancashire delayed a factory project for 3 years simply because he didn't like the look of the prospective owner. Medieval-level pettiness, industrial-age consequences. Legal battles over land rights could consume fortunes. Victorian property law was a maze of ancient rights, tenant obligations, and feudal holdovers that would give modern lawyers migraines for weeks. Sometimes industrialists had to buy out entire villages, relocating dozens of families before construction could begin. Records show one Manchester factory paid more for land acquisition and legal fees than for the entire building itself. The really clever industrialists would scout locations years in advance, quietly buying up parcels before anyone realized what they were planning. Victorian industrial espionage started long before the first brick was laid. With the land finally secured and probably a few gray hairs added to the owner's head, came the next impossible task: gathering enough materials to build a small city's worth of structure. You'd think ordering building materials would be the easy part. Just write up a list, send it to some suppliers, and wait for everything to arrive. But Victorian factory construction didn't work like modern Amazon deliveries. We're talking about moving enough bricks to pave a road from London to Edinburgh. Someone had to organize every single cartload. Let's talk bricks first. A medium-sized factory needed between 2 and 4 million bricks. That's not a typo. Millions. Some of the larger textile mills used upwards of 8 million bricks, enough to keep an entire brickworks running at full capacity for over a year. I can't even count to 8 million, let alone organize that many of anything. Factory records show dedicated brick-making operations being set up just to supply single construction projects. One particularly obsessive clerk's inventory document from a Yorkshire mill ran to over 200 pages, and that was just for bricks. Iron was even more complicated. Victorian factories needed hundreds of tons of the stuff for columns, beams, and structural connections. But here's the problem. Iron quality varied wildly between foundries, and bad iron could bring down an entire building. Factory owners sent their own inspectors to foundries to test batches before accepting delivery. Records show some projects rejecting up to a third of iron shipments for failing quality tests. One factory in Birmingham reportedly fired 3 different iron suppliers before finding one that could meet specifications consistently. Talk about quality control nightmares. Glass presented its own headaches. Factory windows weren't small decorative affairs. Some mills had window walls stretching 60 feet long to maximize natural light. That meant hundreds of large glass panes, each one fragile enough to shatter if a cart hit a pothole too hard. Transport records show glass shipments packed in straw and moved at walking pace, with workers assigned specifically to watch for road hazards. And get this: breakage rates could hit 20% on longer journeys. 1 in 5 panes arriving as expensive garbage. Timber consumption was staggering. Beyond permanent structural uses, factories needed enormous quantities of wood for scaffolding during construction. Some projects used enough timber to strip several acres of forest, and scaffolding poles had to be replaced constantly as they wore out or broke. One particularly frazzled construction manager's diary complained that he spent more time worrying about timber supplies than about actual building work. Victorian project management at its finest. Getting all these materials to the construction site required logistics that would impress modern supply chain managers. Canal barges carried the heaviest loads where waterways existed. Early railways transported iron and specialized components from distant foundries. Horse-drawn carts handled everything else, creating traffic jams on roads never designed for industrial transport. Some factory sites received over 50 cart deliveries per day at peak construction. Medieval roads, industrial traffic. Storage became its own crisis. Materials often arrived faster than they could be used, creating massive stockpiles needing protection from weather and thieves. Construction sites basically became temporary warehouses, with workers assigned full-time just to guard and organize supplies. Theft was constant. Records show one Manchester project losing enough bricks to build a small house before anyone noticed they were disappearing. Someone literally stole a house's worth of bricks, piece by piece. With mountains of materials finally piling up on site, it was time for the really fun part, making sure the whole thing didn't sink into the ground. Victorian foundations were engineering feats that would make modern builders nervous. You can't just stack thousands of tons of iron and brick on regular dirt and hope for the best. That would be like building a house of cards on a trampoline. Entertaining for about 10 seconds, then disastrous. Victorian engineers were basically working with land that didn't want to cooperate, and the consequences of getting foundations wrong ranged from expensive repairs to complete structural collapse. Industrial sites rarely had nice, solid ground waiting beneath the surface. Many factory locations were former marshland, drained and filled, but still unstable underneath. Others sat near coal mines where underground tunnels could shift and settle for decades. Engineering surveys from the era describe ground conditions with phrases like treacherous and wholly unsuitable. Really inspires confidence, doesn't it? One particularly unlucky factory in the Midlands had to relocate entirely after test digs revealed the site was essentially sitting on top of an underground river. Pile driving became the standard solution for difficult ground. Workers would hammer enormous wooden piles deep into the earth until they hit something solid enough to support the building above. We're not talking about a few poles here. Large factory projects required thousands of piles, each one driven by hand or by steam-powered pile drivers working for months on end. Records show one textile mill needed over 3,000 wooden piles before engineers were satisfied. Imagine the noise of that going on for half a year straight. I get annoyed by construction noise after an hour. Portland cement changed everything when it became widely available in the 1840s. This wasn't your grandfather's lime mortar. Portland cement could set underwater and created concrete strong enough to rival stone. Factory builders started pouring massive concrete foundation blocks, sometimes 20 feet thick, to distribute the enormous weight above. Modern analysis of surviving Victorian foundations shows some were so conservatively engineered they could have supported buildings twice their actual size. Talk about playing it safe. Vibration was a problem medieval castle builders never had to consider. Factory machinery didn't sit quietly. Steam engines, power looms, and metal presses shook constantly, and those vibrations could literally shake a building apart over time. Engineers developed isolation techniques, creating separate foundations for the heaviest machinery that weren't connected to the main building structure. Some factories had engine houses that were essentially buildings within buildings, with their own independent foundations sunk even deeper than the factory floor. Foundations within foundations. Very Inception. Foundation depths could get impressive. While ordinary buildings might need foundations a few feet deep, industrial structures sometimes required excavations going down 30 feet or more. Workers digging these pits occasionally discovered things they weren't expecting: Roman ruins, medieval cellars, forgotten mine shafts, and in one memorable case from Sheffield, an entire underground stream that flooded the excavation repeatedly until engineers figured out how to redirect it. Surprise plumbing. Testing methods were surprisingly sophisticated. Before construction could proceed, engineers would load temporary platforms with enormous weights to simulate the pressure the finished building would create. Records describe test loads equivalent to the weight of 10 elephants pressing down on foundation sections for days while surveyors checked for any settling. One particularly paranoid engineer reportedly made his workers wait an entire winter before proceeding, just to see how freeze and thaw cycles affected the prepared ground. With a foundation solid enough to support a small town, Victorian builders could finally start on what made these factories revolutionary: the iron skeleton that would change construction forever. Medieval castles used massive stone walls to hold everything up. Victorian factories had a better idea. Iron frames became the skeleton that let these buildings grow impossibly large, and they changed construction forever. Plus, they looked pretty impressive. Cast iron columns were the secret weapon. These weren't custom pieces laboriously carved by craftsmen. They were mass-produced in foundries, standardized to specific sizes, and shipped to construction sites ready for installation. It's like Victorian IKEA, except the furniture weighed several tons and you definitely couldn't carry it home in your car. And get this, a single cast-iron column could support the weight of 50 horses standing on top of each other. That's both an impressive statistic and a very strange mental image. Factory records show columns being ordered by the hundreds, each one identical, each one capable of holding up enormous loads. Wrought iron beams spanned the gaps between columns, creating distances that stone or timber could never achieve. Traditional brick buildings needed load-bearing walls every 20 feet or so, breaking up interior space and limiting what you could do inside. Iron beams could stretch 40 feet or more without support, creating the massive open floor plans that industrial production required. Tests on surviving Victorian beams show they were often engineered to handle 3 times their expected load. Victorian engineers apparently really didn't want their buildings falling down. The fireproof promise drove a lot of iron construction. Wooden textile mills had an annoying habit of burning to the ground, taking workers, machinery, and profits with them. Cotton dust and oil-soaked machinery were basically waiting for a spark. Just one spark. Iron frames surrounded by brick didn't burn, and insurance companies noticed fast. Records show fire insurance premiums dropping by half or more for iron-framed buildings. Spend more on construction now, save fortunes on insurance forever. Victorian cost-benefit analysis at its finest. Prefabrication was surprisingly sophisticated. Foundries would cast columns and beams to exact specifications with connection points already built in. Workers on site were essentially assembling a giant puzzle rather than fabricating each piece from scratch. I can barely finish a jigsaw puzzle. These guys were doing it with multi-ton pieces. Construction managers kept detailed assembly diagrams showing exactly which column went where and how beams connected together. One particularly organized factory's assembly documentation ran to over 50 pages of drawings. Connection engineering was its own specialty. Bolting iron pieces together safely required understanding how forces would travel through the structure. Get the connections wrong, and the whole frame could fail catastrophically. Not slightly. Catastrophically. Engineers developed standard connection designs that could handle both the dead weight of the building and the dynamic forces from machinery vibrating throughout the structure. Some connection points used bolts as thick as a man's wrist. Column placement had to account for future machinery. Engineers needed to know exactly what equipment would go where, because columns couldn't easily be moved after construction. Floor plans were designed around the anticipated positions of power looms, spinning frames, and other heavy equipment. Getting this wrong meant either wasting expensive column capacity or, worse, discovering your machinery was heavier than your structure could support. Oops. Height achievements became a point of industrial pride. The most ambitious factories pushed to 7 floors, each level capable of supporting hundreds of workers and dozens of heavy machines. These buildings were the skyscrapers of their age. An iron skeleton standing tall was impressive, but it was still just an expensive metal sculpture. The real magic came next, installing the steam engine that would bring the whole beast to life. A factory without power was just a very expensive warehouse. You could have the most impressive iron frame in England, but without something to drive the machinery, you'd just built a monument to wasted money. Steam engines were the answer, and installing one wasn't like having a new appliance delivered. These machines arrived in pieces weighing tons, and getting them wrong could be literally explosive. Steam engines weren't delivered by Victorian Amazon Prime ready to plug in. They came disassembled on multiple wagons, with the largest components requiring special transport arrangements. A major factory engine might have a flywheel alone weighing 15 tons. That's heavier than 3 elephants, and someone had to figure out how to move it from the delivery point to its final position inside the building. Good luck with that. Records show installation crews spending weeks just positioning the main components before any assembly could begin. The engine needed its own foundation within the foundation. We talked earlier about factory foundations handling vibration, but steam engines were a special case. A large engine would shake constantly during operation, and that vibration couldn't be allowed to travel through the rest of the building. Engineers created isolated engine beds, massive blocks of concrete and stone, separated from the main structure by layers of timber and sometimes even sand. One particularly massive engine foundation in Manchester weighed more than the engine itself. Talk about overkill. Boiler installation was where things got genuinely dangerous. These weren't gentle heating systems. Industrial boilers operated under enormous pressure, containing enough energy to level a city block if they failed catastrophically. And they did fail. Victorian newspapers regularly reported boiler explosions killing dozens of workers at a time. Factory inspectors' reports describe scenes of devastation that sound more like battlefield accounts than industrial accidents. One particularly awful explosion in 1856 killed over 30 workers and destroyed half the factory building. Not a typo, half the building. Water supply for the boilers required its own infrastructure. A large engine could consume thousands of gallons per hour, all of which had to be heated, pressurized, and cycled through the system. Factories built dedicated pump houses, water towers, and pipe networks just to keep their engines fed. Some operations employed workers whose entire job was monitoring water levels, because running a boiler dry was a guaranteed path to disaster. Boom! Coal storage presented its own challenges. A hungry factory engine might burn through 10 tons of coal per day, which meant building storage facilities capable of holding weeks or months of supply. Coal yards became small mountains of fuel, constantly being replenished by deliveries and constantly being shoveled into hungry boiler furnaces. The workers who fed the boilers did some of the hardest labor in the factory, working in heat that could reach over 100 degrees. I complain when my office gets stuffy. Chimneys completed the steam system. These weren't modest domestic stacks, but massive brick towers stretching 100 feet or more into the sky. The height was essential for creating proper draft and dispersing smoke away from the factory floor. Some Victorian factory chimneys became local landmarks, visible for miles across the industrial landscape. Building them required specialized skills and considerable nerve, since workers had to construct at heights that would terrify modern construction crews. With the steam engine thundering away, the next challenge was getting that power to every corner of the factory. Victorian power transmission was an engineering marvel that's almost forgotten today. One steam engine, but hundreds of machines that needed power. The solution was a mechanical nervous system running through the entire building, and it was one of the most impressive feats of Victorian engineering that almost nobody remembers today, which is a shame because it was genuinely brilliant. Line shafting was the answer. Imagine horizontal metal shafts running the entire length of each factory floor, mounted on the ceiling or suspended from iron brackets. These shafts spun constantly when the factory was operating, driven ultimately by that single steam engine in the basement. A typical textile mill might have several hundred feet of shafting on each floor, all rotating together in perfect synchronization. It was like Victorian Wi-Fi, except instead of invisible signals, it was very visible spinning metal that could kill you if you got too close. So not exactly like Wi-Fi. Leather belts connected individual machines to the main shafts. Each piece of equipment had its own belt running up to the overhead shaft, and when the shaft turned, the belt turned, and the machine worked. Simple concept, massive execution. A large factory might contain miles of leather belting when you added it all up. And get this, records from one Manchester mill show they replaced over 2,000 feet of belt material every single year just from normal wear and tear. Vertical shafts connected the floors, transferring power from the engine room up through every level of the building. This mill gearing system required precise engineering to ensure power reached the top floors without excessive loss. Studies of surviving Victorian power systems show that factories could lose 30% or more of their engine's output just getting power distributed to all the machines. That's nearly a third of your coal bill, literally spinning away into friction and heat. Alignment was absolutely critical. Every shaft had to be perfectly straight and perfectly level. A misalignment of even a fraction of an inch could cause vibrations that would tear bearings apart within weeks. Factory engineers became obsessive about shaft alignment, developing increasingly sophisticated measurement techniques. One particularly meticulous engineer's notebook describes spending an entire week adjusting a single 50-foot shaft until it ran true. 1 week. 1 shaft. Belt maintenance was a constant job. Leather belts stretched, wore thin, and eventually broke. They needed regular oiling to stay flexible and regular tightening to maintain proper tension. Some factories employed dedicated beltmen whose only job was walking the floors, checking and adjusting belts all day. Breaking belts were genuinely dangerous. A leather belt spinning at high speed and suddenly snapping could take off a worker's arm, and sometimes did. Installing the actual production machinery was the final piece of the puzzle. These weren't lightweight items you could carry in through the door. Power looms, spinning frames, and metal presses weighed tons each. Workers would remove entire sections of wall or roof to lower machines into position using temporary cranes and rigging. Floor loading had to be calculated precisely because different machines required different support. One particularly complex factory's installation plan looked more like a military operation than a construction project. With the machinery finally humming and the belts spinning overhead, the factory was technically operational, but nobody had figured out how humans were supposed to survive working inside this iron monster. That required its own set of engineering solutions. Machines don't care about fresh air or working toilets. Humans do. Making a factory livable was almost as hard as building the thing in the first place, and Victorian solutions ranged from genuinely ingenious to barely adequate. Mostly the latter. Lighting was the first headache. These massive buildings needed to operate for as many hours as possible to pay off their enormous construction costs, but natural daylight only lasted so long. Gas lighting became the standard solution, with pipes running throughout the building feeding hundreds of individual burners. Factory records show gas bills that would make your eyes water. One textile mill's annual gas expenditure exceeded the total yearly wages of its lowest-paid workers. And the light quality wasn't exactly pleasant. Gas flames flickered, produced heat, and filled the air with combustion products that made everyone's eyes sting. I get annoyed by fluorescent lights. These folks had it way worse. Window design became surprisingly sophisticated. Architects learned that north-facing windows provided the most consistent light throughout the day, without harsh shadows or the blinding glare of direct sunlight. Some factories had entire walls made of glass, flooding work floors with natural illumination during daylight hours. The really clever designs included skylights and light wells that could channel daylight deep into building interiors. Of course, all that glass also meant freezing workers in winter and roasting them in summer. Can't win. Ventilation systems attempted to deal with the heat, dust, and fumes that industrial production generated. Cotton dust hung in the air of textile mills. Metal particles filled engineering works. Smoke and steam escaped from countless processes. Factory builders installed ventilation shafts, roof vents, and sometimes even primitive fan systems to try moving air through buildings. Factory inspection reports from the era describe conditions ranging from acceptable to absolutely appalling, often within the same building. Same factory, different floors, completely different air quality. The sanitary question was exactly as unpleasant as it sounds. Hundreds of workers needed toilet facilities, and Victorian plumbing wasn't exactly reliable. Early factories often had ratios of one toilet for every 50 or more workers, which meant constant queuing and conditions that nobody wants to think about too carefully. One particularly grim inspection report described facilities that would get a modern restaurant shut down immediately. Water closets gradually replaced the more primitive alternatives, but many factory owners resisted the expense until legislation forced improvements. Drinking water and washing facilities were equally problematic. Workers needed access to clean water, both for drinking and for washing off the dirt and dust of industrial labor. Some factories provided communal water sources that were barely better than drinking from the river. Others invested in proper filtration and separate facilities. The variation was enormous and largely depended on how cheap the owner was. Heating presented an ironic challenge. Despite all that steam power and all those burning boilers, many factory floors were freezing cold in winter. Heat rose to the ceiling and escaped through all those beautiful windows. Workers near the boiler room might sweat, while those at the far end of the building shivered. Some factories installed primitive heating systems using waste steam, but many just expected workers to tough it out. Victorian workplace comfort at its finest, with lighting flickering, ventilation questionable, and sanitation barely adequate, the factory was finally ready for its most important and most complicated component, the people who would actually run the machines. A factory is only as good as the people running it. You could have the most impressive iron frame, the most powerful steam engine, and the most advanced machinery in Britain, but without trained workers to operate everything, you'd just built a very expensive paperweight. Staffing a new factory was like building a small army from scratch, except with less marching and more machine oil. Recruitment was fiercely competitive. Skilled workers were in high demand across industrial Britain, and the best ones could essentially name their terms. Factory owners would send agents to competing mills trying to poach experienced operatives, sometimes offering signing bonuses that would make modern recruiters jealous. Records show actual bidding wars over particularly talented foremen, with rival owners trying to outdo each other on wages and housing arrangements. One particularly frustrated Manchester mill owner complained in a letter that finding good workers was harder than finding good iron. And get this, some skilled workers would play different factory owners against each other, negotiating better terms at each round. Training took longer than you might expect. Operating industrial machinery wasn't something you could learn in an afternoon. I can't even program my microwave properly. These workers had to master equipment that could kill them. New workers might spend weeks or months learning the basics before they could work unsupervised. Experienced operatives would mentor newcomers, passing on tricks and techniques that weren't written in any manual. Factory records show training periods ranging from 2 weeks for simple tasks to over a year for the most complex machinery. The factory hierarchy was its own little society. At the top sat the owner or manager, rarely seen on the production floor. Below them came the overseers and foremen, responsible for keeping everything running smoothly. Then the skilled operatives who actually ran the machines, followed by the unskilled laborers who did everything else. Some factories employed more people than medieval towns. The largest textile mills had workforces exceeding 2,000, all needing coordination and supervision, basically small kingdoms of spinning and weaving. Time became the new tyrant. Factory work ran on clock time, not the natural rhythms of agricultural labor. Bells and whistles signaled shift changes with military precision. Workers could be fined for arriving minutes late, and some factories even locked their doors once work began. Locked doors. Try explaining that to modern health and safety. The clock tower became as important a feature of factory architecture as the chimney. Records describe elaborate timekeeping systems designed to track every worker's hours down to the minute. Wages and payment systems were surprisingly complex. Many factories used piece rate calculations, paying workers based on output rather than hours. This meant elaborate systems for counting, measuring, and recording production. Some mills employed dedicated clerks just to calculate wages each week. Payment disputes were constant, and factory records include endless arguments about rates, measurements, and deductions. Company housing created entire factory communities. Workers and their families would live in streets built by factory owners, shop at company stores, and attend company-sponsored schools. The factory didn't just employ you, it became your entire world. Opening day was the moment everything got tested for real. After years of construction, the steam engine would fire up and the whole building would come alive for the first time. Newspaper accounts describe crowds gathering to watch new factories begin operation, cheering as the great chimney began to smoke. These Victorian factories would run for decades, some for over a century. But the steam age couldn't last forever. When electricity arrived, it would change everything about how factories were built and powered. But that's a whole different story of industrial revolution.